Alright, in this section we're going to be adding and subtracting the polynomials. So let's go ahead and get started. When we're adding and subtracting polynomials, we again are only going to be able to ever add things that are like terms. So let's just start with this polynomial and simplifying it. So my like terms are anything with the same variable and the same exponent. If they don't have the same variable with the same exponent, they are not considered like. So I've got 15 plus 2, which is 17m cubed, and then this stands alone, so it's 6m squared. The next one, we're also going to make sure that we're writing these in standard form, so I'm going to find the things with the highest degree and add those together first. So I've got 3 and negative 7. That makes negative 4x squared. Notice I'm not changing my term afterwards. It stays the same. And then I have 5 plus 12, which is 17. So I have negative 4x plus 17. And this next one, I've got to look for things that have the same variable with the same exponent. So if you will look here, this has a b cubed c squared. This also has a b cubed c squared, and this has a b cubed c squared. So these actually can all be added together. And what that will do is create what we would call a monomial, a single term. So 9 plus 5 is 14 plus negative 13 is just a 1. 1 b cubed c squared. Now the 1 is unnecessary, so we really would just write b cubed c squared. This is the way a lot of our problems are going to look, and they're going to look like we're going to add polynomials together. Being more specific in this would be a binomial that has 2 terms plus a binomial that has 2 terms. What is really going on here is there's a 1 that sits in front of each of these parentheses. The 1s, when you distribute, does not change the problem inside. So if I distribute a 1 here as well, I get an 8m squared and a 5. When I add my like terms, I get 20m squared, and then I have 4 plus 5, which is 9. My next problem, again, I'm adding like terms. So again, there's those 1s there. I'm not going to show you that. We know that the 1 is not going to change anything. So really, the parentheses are unnecessary. So when I add my like terms together, I have 1 plus 3, which is 4t squared. And then I have negative 6 plus 11, which is 5. So I end up with 4t squared plus 5. My next problem, I have addition again, so the parentheses do not matter. So I can just go ahead and rewrite this without any parentheses, and then add my like terms. I've got 9 and 7, those are both w cubes. That gives me 16w cubed, plus, there's only a w squared, 8w squared, and then I'll put plus 4. And my next one, this is my last sum problem. So I will again replace or just rewrite everything without the parentheses because it's like I'm distributing a 1 through. And I'm distributing a 1 through again. So I end up with exactly what's inside the parentheses. So 2p cubed plus 9p cubed is 11p cubed. Then I have 6p squared and 11p squared, which would be 17p squared. And the last one, 10p and 3p, gives me 13p. On the next video, I will show you how to simplify differences. Alright, starting on this slide, you'll notice that before we had plus signs between here, and now I have subtraction. So I'm going to be finding the difference in each of these. Again, there's a 1 that sits out front. So this first one does not change. It's still v cubed plus 6v squared minus v. However, the second one, there's really a negative 1 that's being distributed through. So what I really have, if I would change my signs, and I'm going to do that in red, to plus the opposite. I have a negative 1 times 9, which is negative 9v cubed, I change my signs here. I have a negative 1 times a negative 7, which is a positive 7v squared. And then I have a negative 1 times a 3, which is a negative 3v. So you can think about distributing a negative through, or if I show you by erasing this stuff again, really what we're doing is we are just changing the signs. So this was a positive 9, now it's a negative 9. This was a negative 7, now it's a positive 7. This was a positive 3, now it's a negative 3. And that's again because you're distributing this negative through. So now I'm going to add like terms. I have a 1v cubed and a negative 9v cubed, which would be a negative 8v cubed. I have a 6v squared and a 7v squared, which is a 13v squared. And then I have a negative 1 and a negative 3v, which gives me a negative 4v. My next difference problem, again, I'm going to be distributing a negative through. So this first one doesn't change because it has a 1 out front, so it does not change. The second one changes. I'm distributing a negative through, so I have 2, a positive 2. It becomes a negative 2 because I'm distributing a negative through. I have a positive 1, which becomes a negative d squared because I'm distributing a negative through. I am going to change my signs to plus the opposite before I start adding my like terms. And then I'm going to look for d cubes. So I have 2d cubes here. I've got 30 and negative 2, which is 28 d cubed. I have negative 29 and negative 1, which is a negative 30 d squared. And then I just have this negative 3d left over. Let's do 2 more of these. This next one, I have a negative I'm distributing through. So I've got 4x squared plus 5x plus 1. And then I'm distributing a negative through, so I've got a negative 6x squared, a negative x, and a negative 8. So when I add my like terms, I get a negative 2x squared, 5x and negative x is positive 4x, and then a 1 and a negative 8 is a negative 7. Last problem. Again, distributing a negative through, subtracting each one. So I've got a 10p to the second plus 5. I have a negative 7p squared. It was positive 7, now it's negative. I have a negative times a negative, which makes a positive 2. I have a negative times a positive, which is a negative 3. So it was positive, now it's negative. It was negative, now it's positive. It was positive, now it's negative. All you're really doing is changing each of the signs when you're distributing the negative through. 10p squared and negative 7p squared was 3p squared. I have a 2p, and I have 5 and negative 3, which gives me 2.